Welcome back to the Deep Dive. Today we are opening the books on one of the most critical topics for any organization that's really trying to move toward an IT as a service model.
A really politically sensitive one, too, a lot of the time.
Oh, for sure. We're tackling that fundamental question of governance. How do you account for value? How do you inject some real financial discipline into this service-centric world?
Right.
We're pulling the curtain back on the financial mechanisms that translate all that raw technical stuff,
Yeah.
gigabytes of storage, CPU cycles, into clear, understandable business costs.
That's absolutely right. Our mission today is to really navigate the core concepts in Module 4, Lesson 3.
Right.
And it's all about financial management models, chargeback and showback.
Right.
This is the step that moves IT out of being this mysterious cost center that just asks for more money every year.
Yep, the black box.
The black box, exactly. And it establishes IT as a transparent, competitive, and, a strategic business partner. We'll clarify what these terms mean, why they're so essential for efficiency, and then we'll get into the three main models for allocating costs.
And this might sound like it's just, accounting jargon.
Yeah.
And yeah, it involves finance, but understanding this stuff helps you, the listener, not just budget better. It fundamentally changes the dynamic.
The behavior.
The behavior between IT and the business units, your lines of business, or LOBs, and how they think about and consume resources. It's a huge shift.
It's powerful.
Okay, let's unpack this, starting with the core definitions: transparency and accountability. So when IT moves to a service model, it has to function like a utility company.
Yeah, that's a perfect analogy.
Utilities don't just send a flat bill, they meter everything. And the way IT does this falls under two main concepts. Let's start with the one where actual money changes hands: chargeback.
Chargeback is, it's exactly what it sounds like. It's the ability for the internal IT provider to charge its consumers, the LOBs, based directly on the resources they've consumed.
And this isn't theoretical.
No, not at all. This requires a robust, working, very detailed metering capability across your entire infrastructure. And, crucially, you need an established, transparent pricing list for every single service.
Because if the metering is wrong, the whole thing falls apart.
Instantly. The business will challenge every single bill. Trust is gone.
Okay, so what about showback? That sounds a little bit like the training wheels version of this.
That's a great way to put it. Showback is exactly that. It's a necessary first step that's all about financial transparency, but it stops short of actually collecting money.
So you're just showing them the bill.
You're just showing the consumer, usually with a detailed monthly report, what the charge would be. It says, here's what you would owe us if chargeback were on. But IT doesn't actually send an invoice or collect the money.
So why bother? I mean, why go through all the effort of sophisticated metering just to send out a fake bill?
Because you need that data. Both models are fundamental for making smart strategic decisions. And showback, it gives you the political groundwork for a full chargeback implementation later on.
How so?
Think about it. How do you figure out the true cost of deploying a service internally? Let's say a high compliance database on your private cloud. How do you compare that to using an external provider?
You can't, not without the data.
Exactly. Without showback data, IT can't do a real objective total cost of ownership analysis to figure out if private, public, or hybrid is the best model. And you can't set competitive internal prices if you don't even know your own costs.
So for the listener, the immediate value is just massive cost transparency. That builds confidence in IT. But why is transparency always cited as this big vehicle for lowering IT spending?
It's all behavioral. It's
Yeah.
purely behavioral. Transparency injects accountability right into the process of consumption.
Right.
When IT resources, VMs, compute, storage, when they feel free or they're just buried in some central budget, the LOBs have zero incentive to be efficient.
They overconsume.
They overconsume, they leave things provisioned but idle, what we often call zombie servers. They just don't care about efficiency. Showback immediately starts to correct that behavior.
Zombie servers. That's a great term. We've all seen them. VMs spun up months ago for a test that's long over, just sitting there chewing up power and licenses.
Precisely. And showback gives you a clear bill that shows the cost of those idle resources. It forces the LOBs to make rational, informed business decisions.
Because otherwise, the LOB that's wasting the most isn't paying for it. Everyone else is.
Right. Everyone else is subsidizing their waste. Showback highlights who's driving the costs, and that's really the first goal of this whole transformation. Improve cost transparency to show value and compel people to be efficient.
But wait a second. Implementing true chargeback. That requires some incredibly sophisticated tools. You're talking about real-time measurement across this highly virtualized infrastructure. Isn't the technical overhead just so high that it cancels out the savings, especially for smaller companies?
That is a very valid point, and yeah, the barrier to entry is high. You absolutely need a good configuration management database, a CMDB. You need discovery tools that can map everything.
You need more than just is it on or off.
Oh, way more. You need sophisticated utilization tracking, things like CPU ready time, storage IOPS, network traffic. But you have to see the cost of that metering system as an investment in strategic control.
Right.
If you're a large organization and wasteful consumption, the zombie servers, the over-provisioning, if that adds up to millions a year, then the investment in a chargeback system pays for itself very, very quickly.
Yeah.
It shifts IT from being reactive accountants to proactive strategists.
So it's not just about tracking what you spent last month. It's about strategically controlling what you're going to spend next month.
Exactly. And this transparency, it lets the IT organization anticipate and justify demand for new resources much more clearly before they buy them.
So you're not just saying, we need 10 million for new hardware.
Right. You're saying, based on last quarter's showback data, Business Unit X used 20% more compute, which lines up with their launch of Product Z. We need to provision capacity tied to that specific business outcome. It proves IT's value instead of just contributing to this massive, opaque budget.
Okay, here's where it gets really interesting for me. We're moving beyond just tracking costs to actually shaping business behavior. Once you get a clear chargeback model going, you create these powerful incentives. And that behavioral shift is the real prize, isn't it?
It is the primary goal. We're talking about incentivizing the highly efficient use of every single resource. If resources feel free and unlimited, they get wasted. It's just human nature. By linking consumption directly to a cost through chargeback, you direct the LOBs, sometimes immediately and pretty dramatically, toward efficient use. You align their habits with the organization's financial goals. This is all about right-sizing demand.
Let's pause on that term, right-sizing. It's critical here. And you also mentioned right sourcing in the intro.
Yeah.
Can we define what right sourcing means in this context?
Sure. Right sourcing is the whole strategic process of picking the best source for a particular IT service. You're balancing cost, performance, risk, governance, all of it.
And chargeback helps with that.
Chargeback data enables it. It gives you the objective cost basis you need to compare. Should we run this app on our internal private cloud? Should we use a managed service provider? Or should we just move it to AWS or Azure?
Without chargeback, you're just guessing at your internal costs.
It's a complete guess, and so right sourcing is impossible.
So that's how it enables the comparison. But let's go back to the incentives. You mentioned right-sizing demand. How does that work in practice?
Well, a consumer knows that provisioning a high availability cluster today costs 50 times more than a standard VM tomorrow. So they're forced to think critically, do I really need this now? Do I really need that much redundancy?
And chargeback facilitates this through tiered services.
It does. It creates a direct, defensible link between quality, performance, and price.
So higher SLAs, higher costs.
Exactly. Higher service levels, the guarantees of uptime, low latency, rapid recovery. They naturally have a higher operational cost. Chargeback makes that cost difference totally visible.
Which lets the LOB make an informed choice.
A truly informed decision. Does this workload really need the most expensive 5 nines uptime tier? Or is a cheaper 99.5% option good enough? It forces the LOB manager to actually evaluate the business value they get for every dollar they spend on IT performance.
This whole concept seems to push the internal IT department into an almost aggressively competitive mindset. They're acting like an external vendor.
That is the very definition of the ITS transformation. Internal IT has to see itself as a competitive service provider.
They have to benchmark themselves.
They have to. Their internal cost to serve has to be researched, monitored, and benchmarked against the market. Because if the public cloud, say, Google or Azure, offers the exact same service cheaper or faster,
the LOBs will just go around IT.
They have an immediate, irresistible economic reason to bypass internal IT. And that's how you get a massive proliferation of shadow IT.
And as the source material points out, IT shouldn't fight that. Not if it offers better value.
Absolutely not. Fighting shadow IT is a losing battle politically, and it's strategically dumb if the external provider is genuinely better. The best practice is for IT to evaluate that shadow IT. Understand the value proposition that's driving the LOB's decision.
And if it's a better option,
then IT shouldn't fight it. IT should broker it.
Let's clarify what brokering means here, because this is where IT really holds on to its strategic value. What does IT control when it becomes a shadow IT broker?
Great question. When IT acts as the broker, it keeps control of the crucial governance functions. First, security and compliance. IT makes sure the third-party contract meets regulations, handles the security audits, and integrates identity and access management.
Okay, so they're the gatekeeper for risk.
They are. Second, IT manages the contract and the finances. They can negotiate enterprise discounts the LOB could never get. They handle the billing, and they make sure those costs feed back into the company's own chargeback system.
And the third piece.
Integration support. IT makes sure that external service actually connects and works reliably with the core enterprise systems. So IT transforms from being a hardware owner into the indispensable strategic curator of all the technology the business uses.
So by providing that cost transparency through chargeback and then embracing public providers by brokering them, the perceived value of IT just skyrockets.
Really does.
You go from being a cost center or a roadblock to being a respected business partner.
That is the definitive goal. And, I want to inject the financial context here, specifically CapEx versus OpEx. This is so important for understanding why CFOs love this stuff.
Please do. I think a lot of listeners know the terms, but maybe not the strategic weight they have here.
Okay, so capital expenditure, CapEx, is money spent on physical asset servers, network gear, data centers. It's an asset on the balance sheet, depreciated over years.
The big, chunky, upfront investment.
Exactly. Operational expenditure, OpEx, is the day-to-day spending, utilities, licenses, and critically cloud consumption. It's an immediate expense.
And the LOBs using a chargeback system, they would much prefer OpEx.
Yes, often dramatically. Chargeback and the pay-as-you-go model, they turn IT spending into OpEx. And the CFO loves this because OpEx spending is agile, it's variable, and it's directly linked to generating revenue.
So if a business unit launches a new service,
and they consume $100,000 in cloud resources this month, that cost is immediately offset against the revenue that new service generated. CapEx, on the other hand, it requires these huge, risky, upfront investments with long depreciation schedules, often way before you see any revenue. Chargeback lets the LOB manager scale costs incrementally. It aligns spending precisely with value.
So it's not just about saving money, it's about making the whole financial structure of IT spending agile enough for the modern business.
Exactly. It's moving IT funding from speculative investment, which is CapEx, to a service utility, which is OpEx. Now, to get to that level of transparency and competition, you need some extremely sophisticated pricing structures. Pricing is really dynamic, and it varies a lot across the three NIST service models, IaaS, PaaS, and SaaS.
And it's influenced by a ton of factors.
Right, like the resource tier, the SLA you need, the contract period. But the key rule here is this. The more granular your metrics are, the more flexible and sophisticated your pricing models can be.
Let's talk about that granularity challenge for a minute. Infrastructure as a service, IaaS, that seems pretty straightforward. You measure CPU, RAM, storage. It's tangible.
It is.
But how do you meter usage in a platform as a service or a software as a service world where all that underlying infrastructure is completely hidden from the user?
That's the core technical problem you have to solve. For IaaS, you measure commodity resources. For PaaS, you have to measure transactions or logical consumption.
What does that mean, logical consumption?
So if you offer a managed database as a PaaS service, you can't bill the LOB for the CPU on the server. They don't see it. You have to bill them for the number of queries they run or the amount of data they transfer or the transaction volume.
You might even break it down into things like GET input operations.
Exactly. The cost driver shifts from raw horsepower to business activity units. For SaaS, you're usually billing per user license or maybe per a defined business activity.
That makes the metering system just exponentially more complex. Can you give us an analogy for just how granular we're talking with this transaction-based pricing?
We are talking about the ability to measure down to the individual event. Think about your old mobile phone bill. It used to itemize every text, every call, every bit of data.
Right.
Now apply that idea to a core business process. If IT is providing a critical message queue service, the metering system has to capture every single message put onto that queue, the PUT operation, and every message taken off, the GET operation.
And then you can figure out the exact cost per transaction.
You can. A high-priority PUT might cost, say, 1/10 of a cent, while a low-priority DT costs 1/100th of a cent.
And that level of detail is necessary not just for the bill, but so the LOB can actually understand where its costs are coming from. It connects the service to a cost center inside their own department.
Exactly. That transparency builds confidence, it eliminates billing disputes, and once you have that granularity, you can start to implement these really flexible consumption models. So let's break down the four common ones from the source material.
Okay, first up, the most predictable one, the subscription-based model.
Right. This is a fixed fee for a defined period, a fixed monthly or annual rate for a certain amount of capacity. It's just like paying for enterprise software or your Netflix account.
So the big advantage is predictability.
Excellent cost predictability for the consumer, and it makes IT's budgeting a lot simpler. The downside, though, is utilization risk. If the LOB consistently underuses their subscription, they're wasting money.
And if they overutilize.
IT has to eat the cost of that excess capacity until the next renewal. So it's a trade-off between simplicity and accuracy.
Okay, next up is peak usage. This one sounds like it's explicitly designed to punish waste and curb demand spikes.
That is its core purpose. With this model, your billing is based on the highest resource use you reach during the entire billing cycle. The 95th percentile, for example.
So even if I only use 5% of my capacity for 29 days, if I hit a huge spike on day 30, I'm paying for that spike for the whole month.
You are, and this actively encourages LOBs to flatten out their demand curves. It makes them manage their spikes and improve efficiency, maybe by shifting non-critical jobs to off-peak hours.
The third one is pretty simple, user-based. I see this a lot for shared services.
Yep, it's a fixed cost per authorized user license, or per seat. It's super common for internal SaaS apps or shared platforms like email or collaboration tools.
The advantage is that it's simple to manage.
Very simple. You just count the number of employees who have access. The weakness is that it completely ignores how much each person actually uses the service. A power user might generate 20 times the cost of a casual user, but they're both billed the same fixed amount.
Okay, finally, let's talk about that super granular one you mentioned earlier, the ticket-based model. This sounds extremely advanced and really tied to quality of service.
It is the most niche and specific of the four. It's used almost exclusively in environments where you have to maintain critical quality of service at all times, often measured in seconds or minutes.
It uses electronic tickets as a kind of currency to control access.
Exactly. It's a way to ration access to guarantee granular control of the overall system load.
Okay, so walk me through how that would actually work.
Imagine a massive shared data warehouse, thousands of queries hitting it at once from different LOBs. If everyone queried it at the same time during a peak period, performance would just die for everybody.
Right.
The ticket-based system manages that load. Before an application can run a query, it has to request an electronic ticket. And the system only grants that ticket to query the database if the current system load latency, CPU, whatever, is below a critical threshold.
So if the system is already stressed, no ticket is granted, and the request has to wait.
Precisely. The transaction gets queued up, and the LOB only pays for the ticket when the transaction finally runs successfully. This mechanism ensures that the system maintains its performance for the critical, time-sensitive apps. It prioritizes stability over just letting every single request run immediately.
That is a fascinating example of how a pricing model can be used for technical governance and to ensure stability. It really shows that link between the financial structure and operational resilience.
Absolutely. The complexity of these models just highlights that moving to IDPA isn't just a tech refresh, it's a fundamental overhaul of how you engage financially.
Okay, so we've covered how consumption is measured and how we can charge for it with different pricing models. Now let's look at the foundational architecture of the resource pools themselves.
Right.
This section gets into the three big allocation methodologies. They're based on resource commitment, and they really dictate the whole chargeback structure and, maybe most importantly, how you manage business risk.
These three models, they define the contract, really, between IT as the provider and the LOB as the consumer. It's all about resource availability, guarantees, and financial predictability.
And picking the right one is a huge part of the planning process.
It's a crucial part. It directly impacts your service cost and its reliability.
Let's start with Model 1, pay as you go. This is the one that really embodies that elasticity the cloud promises.
It is the poster child for cloud agility, for sure. The mechanism here measures either what you've provisioned or what you've actually used, often on an hourly or even transactional basis.
And the key is you only pay for what you use.
Only for what you use, with little to no long-term commitment. It's a direct mirror of the public cloud utility model.
So if my demand spikes 400% over the holidays, my bill spikes, but I get the resources I need immediately. And if my demand is 0 in January, my bill drops to almost nothing.
That is the core benefit. elasticity and risk mitigation. This model is perfect when your demand is unpredictable or highly variable or temporary.
It gets rid of the need for those big CapEx investments, just to cover a peak that might only happen once a year.
Right. It lets your costs scale up or down immediately with your needs. Perfect for test environments, dev workloads, or new business ideas where you have no idea what the demand will be. And financially, it aligns perfectly with the CFO's desire for low CapEx and agile OpEx spending.
But the drawback has to be the volatility, the uncertainty in the monthly budget.
Precisely. While the unit cost is efficient, the total monthly bill is highly unpredictable. If an LOB isn't disciplined about shutting down idle resources, or if a bug causes a huge utilization spike, the manager can get some serious sticker shock when that bill comes in.
So you need really strict governance and monitoring tools to go along with it.
You have to have them.
Okay, moving on. Model 2 seems like a blended approach that introduces a lot more complexity. Variable resource commitment.
It's a really practical compromise. It's designed to balance cost effectiveness with a guaranteed level of service. It's trying to manage the risk you see in the pure pay-as-you-go model.
And how does it work?
The mechanism is that you make a total pool of resources available to the consumer, but you split that pool into two parts. A pre-agreed, fixed, guaranteed percentage.
Something they know they'll always have.
Right. And a shared pool percentage. And that shared pool is contended. It's available to other consumers too, which means that burst capacity is never 100% guaranteed.
That must require some complex negotiations. The LOB manager has to decide how much risk they can live with in that shared pool versus the cost of guaranteeing more capacity.
It's absolutely a political and technical negotiation. The LOB defines their minimum baseline need, let's say 60% of their peak usage, and they commit to paying for that guaranteed slice no matter what.
And that gets them a fixed, assured level of performance.
It does. The other 40% is drawn from that shared bursting pool as they need it.
And how does the billing reflect that dual commitment? Guaranteed versus burst.
So the consumer is billed at two different rates, and this is key to the incentive. They pay one rate for the resources they use within that guaranteed pool. That rate is typically cheaper, more stable, because the LOB made a commitment.
And that minimizes IT's risk of having idle hardware.
Exactly. But then they pay a separate and potentially much higher premium rate for anything they use from the shared pool. That higher rate reflects the cost to IT of managing all that elasticity and contention in this shared environment.
That's a clever way to encourage stability but still keep some flexibility. The LOB has an incentive to stay within their baseline to save money, but they have a safety net if a spike happens.
It manages that twin risk of over-provisioning, which you see in dedicated models, and resource volatility, which you see in pay-as-you-go. The one thing IT has to be careful about is not to oversell that shared pool.
Right, because if everyone tries to burst at once,
You'll get performance degradation and failures, and that undermines everyone's confidence in the entire model. It requires constant monitoring and transparent capacity planning.
Okay, finally, we have Model 3, dedicated resources allocation. This sounds like the complete opposite of elasticity. It's fixed, it's guaranteed.
In terms of resource assurance, it is the highest level you can get. The mechanism here is that resources, a server cluster, a set of virtual cores, whatever, are reserved and guaranteed exclusively for one consumer.
They are not shared with anyone else.
Not at all. It ensures absolute isolation, predictable performance, and it helps meet some of those really strict regulatory requirements that demand physical segregation.
And the financial side of that exclusivity is a fixed cost, I assume.
Yep. The consumer pays a fixed, predictable amount for those reserved resources, usually in a longer-term agreement, even if they don't use all of them.
And that's critical for mission-critical applications.
Absolutely. Things like core financial trading platforms, compliance logging systems, or maybe legacy apps that just can't tolerate any latency variation.
But the trade-off is painful. It's utilization efficiency. You're paying for those resources to just sit there when demand is low.
That's the deal. If the resources sit idle half the time, the organization still pays 100% of the cost. It inherently leads to lower utilization, but for certain workloads.
The ones tied to major risk.
Right, the ones tied to regulatory risk or life or death operational decisions. For those, the guaranteed performance outweighs the financial inefficiency. The choice of this model is really a strategic risk decision disguised as a financial one.
This really highlighted a key takeaway for me. An IT leader isn't just picking one financial model. They're acting as a strategist, applying the right financial and commitment model to the right workload.
That is the perfect way to synthesize it. A large organization will almost certainly use multiple allocation models at the same time.
You might have the finance department's trading platform on the high-cost, high-assurance dedicated model.
And the test and dev team on the highly variable pay-as-you-go model for their temporary environments. Matching the allocation model, the consumption model, and the service tier based on cost, capability, and trust, that's the most crucial part of the whole cloud planning process.
And this choice loops right back to the need for cost transparency. If IT decides to put the data warehouse on a high-cost dedicated tier because of latency needs, they have to be able to justify that premium cost to the business unit.
And chargeback lets them do that with detailed cost apportionment.
But
The end goal is to move beyond just lumping all IT spending together for the whole company. You want to accurately apportion that spending to individual workloads based on their real share of the cost drivers. That's what lets you do a true apples-to-apples comparison between internal and external options before you commit to anything.
So we've really covered the fundamentals of chargeback and showback, and not just as, ways to move money around internally, but as these critical tools for injecting accountability, efficiency, and even competition into IT service delivery.
For sure.
We saw how that granular metering, right down to the API transaction, lets you have flexible pricing, from fixed subscriptions to peak usage, and even that really controlled ticket-based model.
And crucially, we detailed those three core allocation models. Pay-as-you-go for elasticity, variable commitment, which blends the guarantee with shared pooling, and dedicated allocation, which prioritizes guaranteed resources over efficiency.
And those models really define the risk, the performance, and the cost for every single service.
That's right, they're the foundation.
The ultimate takeaway here seems to be that implementing chargeback isn't about IT becoming a profit center or collecting revenue. It's about changing the business culture and making IT indispensable. It's about making sure every single dollar spent on IT drives measurable strategic business value. And by providing this transparency, IT helps the LOBs become these proactive, informed stewards of the company's money.
And that transforms IT into that strategic, trusted partner that it really needs to be in this IT's world.
It's a huge shift.
And this approach, it forces IT to act like a business itself. It shifts the focus to a rigorous cost-to-serve analysis.
Which means IT can't just track the obvious costs.
No, you have to track direct costs like hardware and licenses, but also the indirect costs, power, cooling, floor space, and critically, the overhead costs like staff salaries, training, and depreciation. Only when you complete that full cost apportionment can IT provide a truly competitive, defendable price for its services.
That cost-to-serve calculation is the heart of it all. If internal IT can't calculate its true, fully burdened service cost, including all that overhead, it can never really compete with the scale and agility of external vendors.
It creates a virtuous cycle, though. The need to implement chargeback drives the need for a cost-to-serve analysis, which in turn drives operational efficiency, which lowers costs, which makes internal IT more competitive.
So what does this all mean for the future of IT funding? If internal IT is constantly being forced to compete with the dynamic pricing and agility of the public cloud through these chargeback models, it raises a big question for you, the listener. In a decade, will the internal IT department even need large, centralized capital expenditure budgets anymore? Or will every single investment, from a new server rack to an extra storage license, be justified solely through a competitive OpEx-driven service catalog, proving its value in real time against the open market? Something powerful to think about as you continue your journey toward becoming a truly service-centric organization.